Good afternoon, everybody, and welcome to the Humanities Forum. My name is Ian Bernhoft. I'm the coordinator of the forum. And the forum is an initiative of the Humanities program at Providence College that offers our community a chance to learn from and speak with leading scholars, professionals, and journalists from around the country and around the world. So it's an opportunity for us to come together outside of the classroom to engage in a shared intellectual life, to deepen our appreciation for the humanities, and to explore diverse perspectives from on and off campus. And it's especially an opportunity to ask some of the bigger questions. Like, for example, the fact that all of us in this room aren't just alive, but we're also conscious of the fact that we're alive, and we can reflect on that. And where did that come from? And how do we account for such a phenomenon? Today's talk is going to grapple with that question. It's part of our St. Albert the Great annual lecture in honor of Louis Verza, which has been sponsored by a generous gift from Louis Verza's family and to the program. We're extremely grateful to them for that. And the talk, the subject of the Albert the Great lecture each year is on this the intersection of science and religion. Now, before I hand the microphone over to Dr. Keating to introduce our speaker, I want to give you a brief rundown of the expectations that you should have for us, and we'll have for you. So the first is that the talk is going to run for about 35 to 45 minutes, and at the end of the talk, there's time for Q&A. We always wrap up by around 4:45, so you've got a little bit of time for questions and answers. And what you should know, if you've been to one of these before, you do know, is that a student has to ask the first question. So if your professor's here, it don't matter. If your parents are here, they're of no help to you. The question has to come from you. Finally, I would strongly encourage, and indeed request, that you close those laptops down and use your eyes, your ears, pens and paper, things that don't glow and distract you unduly. We're going to record it. It's going to be on YouTube. You can go back if you need to. Okay, and then the last thing that you should know is that at the end of our talk, head down the hallway in the great room, the Fiondella great room. There's a reception, got some tasty food and drinks. It's a great way to start your weekend, so you can continue the conversation down there. All right, with that, I will present Dr. Jim Keating.
Good afternoon. Providence College presents itself and aspires to be a liberal arts college. It's on all our advertisements. If that is to mean anything, it must be that the sciences, which are part of the liberal arts, and the humanities belong within the same intellectual and educational project. Although this used to be a truism of sorts, and many colleges and universities were built upon this conviction, it is now far from a consensus. Indeed, we struggle to bring these two worlds together in any non-trivial manner. However, if we cannot, a liberal arts education is a fantasy. It is therefore essential for a forum dedicated to the humanities, this is the Humanities Forum, to provide examples of how science and the humanities can operate together in the search for the truth. This joining cannot happen if the truth about human beings is known solely through the natural sciences, with the humanities an interesting but non-informative ornament. It is for this reason and other reasons that we are so happy to welcome Dr. Stephen Barr today to address the question of whether human consciousness is reducible to physics. Stephen Barr is an American physicist who is a professor emeritus of physics at the University of Delaware. A member of its Bartol Research Institute, Barr does research in theoretical physics, or maybe did research, I don't know, does research in theoretical particle physics and cosmology. In 2011, he was elected a fellow of the American Physical Society. The citation reading for his original contributions to grand unified theories, CP violation, and baryogenesis. Dr. Barr is also an old friend of Providence College, and he's visited a number of times. So please join me in welcoming him back.
Thank you for that introduction, and thanks to Providence College for inviting me to speak here again. I have been here 2 or 3 times in the past and enjoyed every visit, and thank you for coming out to hear me. So let me just check that these arrows do what I want them to do. Okay. So my talk is, can consciousness be reduced to physics? Carl Sagan, the well-known astrophysicist and science popularizer, once wrote, quote, "I am a collection of water, calcium, and organic molecules called Carl Sagan. You are a collection of almost identical molecules with a different collective label," unquote. Strange as that assertion may sound, it expresses an idea that many of our contemporaries regard as so obvious as to be beyond dispute. The idea is called physicalism and holds that all of reality, including the human mind, is ultimately nothing but matter in motion, and therefore explicable in terms of physics. This philosophy, it has ancient roots, but in its modern form was inspired by a number of scientific developments, which is why it is sometimes called scientific materialism. One of those developments was Newton's discovery in the late 17th century of the laws of mechanics and gravity that now bear his name. Those laws were universal because they applied to all matter throughout the universe, and deterministic because they rigidly and uniquely determined how events would unfold from any given starting point. A classic statement of physical determinism was made by the great mathematician and physicist Pierre-Simon Laplace in 1814. He wrote, "To an intelligence which could know all the forces by which nature is animated, and the states at some instant of all the objects that compose it, nothing would be uncertain, and the future would be present to its eyes." Now, all of the fundamental mathematical laws of physics discovered in the 2 centuries after Newton were also deterministic, and this gave rise to the idea that the physical world is a closed system of cause and effect, with physical effects being entirely accounted for by prior physical causes. This is often called the principle of causal closure of the physical world. Now, despite the fact that nature seemed in this way to be in the iron grip of the laws of physics, many scientists and other thinkers continued to believe that life and mind must be exceptions and involve the operation of non-physical forces and principles. But with respect to life, this view was undermined by scientific advances in the 19th and 20th centuries that showed that the processes that go on in living things are based on the same chemical elements and the same chemical laws found in non-living things. And with respect to mind, it is hard to see how it could be an exception if the principle of causal closure is assumed to be correct. Our thoughts, for example, our beliefs, obviously affect our actions and therefore affect the physical world. And so if physical effects can only have physical causes, our thoughts themselves must be physical, just physical entities. As a science writer in Newsweek once baldly put it, quote, "Our thoughts are not mere will-o'-the-wisps, ephemera with no physicality. They are instead electrical signals." It should be noted that the discovery of quantum mechanics in the 1920s showed that the laws of physics are not, in fact, deterministic and do not rigidly determine how events will unfold. Strangely enough, however, this has not shaken the belief of many philosophers in the principle of causal closure of the physical world, which therefore now seems to be supported more by ingrained philosophical prejudice than by anything science has actually discovered. The idea that minds are machines and thoughts are electrical signals started to gain ground with the development of programmable electronic computers in the late 1940s, after which the term thinking machines became widely popular. And now we have reached the point where machines can outthink us in activities whose mastery was once considered to require great intelligence, if not genius. For example, the chess-playing programs Stockfish and AlphaZero are now much stronger than the best human chess players. At the same time, rapid advances in neuroscience have demonstrated, sometimes in dramatic detail, the intimate connections between particular physical structures and processes in the brain, in the human brain, and particular mental phenomena. Many therefore regard it as axiomatic that neuroscience will eventually be able to account for every aspect of our minds. So when Sir Francis Crick, co-discoverer of the structure of DNA, wrote in one of his books, "You, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will are in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. As Lewis Carroll's Alice might have phrased it, you're nothing but a pack of neurons," unquote. Now, one reason that physicalism is an attractive philosophy, that is the idea that everything is just matter, is that it promises a single, simple, and all-embracing explanation of reality. It thereby satisfies the natural desire of the human mind for unity and simplicity in its understanding of the world. This striving for unity and coherence was well described by St. John Paul II in his 1988 letter to the director of the Vatican Observatory. He wrote, "Unity involves the drive of the human mind towards understanding. When human beings seek to understand the multiplicities that surround them, when they seek to make sense of experience, they do so by bringing many factors into a common vision. Understanding is achieved when many data are unified by a common structure. The one illuminates the many. It makes sense of the whole. Simple multiplicity is chaos. And insight, a single model, can give that chaos structure and draw it into intelligibility." This striving has been rewarded with enormous success in physics. Indeed, the whole trend of theoretical physics for the last 400 years has been toward an ever more unified conception of physical phenomena. First, Newton showed that the same laws govern celestial and terrestrial phenomena. Later, Newtonian mechanics was able to explain phenomena as diverse as the motion of fluids, the propagation of sound, and the flow of heat. In the 1860s, James Clerk Maxwell showed that electricity, magnetism, and optics are all aspects of a single force now called electromagnetism. In 1905, Einstein showed that space and time form a unified whole, a unified four-dimensional whole, and that mass and energy are really the same thing. In the mid-20th century, quantum field theory showed that forces, wave phenomena, and particles are all manifestation of a single underlying reality called quantum fields. And now physicists are closing in on a single unified theory of all of physics, which may well be so-called superstring theory. It seems very natural, therefore, to imagine that we are headed toward an even grander synthesis in which not only matter, forces, space, and time, but all of reality, including mind itself, will be shown to be explained by a single theory of physics, a theory of everything. But there's a danger in pushing any idea too far. It is possible to desire unity and simplicity of explanation so strongly that one is satisfied to obtain it on the cheap by ignoring or discounting what does not fall within one's scheme. Einstein said in a lecture in 1933, quote, "It can scarcely be denied that the supreme goal of all theory is to make the irreducible basic elements as simple and as few as possible without having to surrender the adequate representation of a single datum of experience." The fatal mistake of physicalism is precisely that it has surrendered a very important datum of experience, namely experience itself. Obviously, there can be no data of experience unless there's experience. And there can be no experience without a mind that can have experiences, in other words, consciousness. What I shall be claiming in this talk is that physicalism or materialism cannot account for consciousness. Now, when I speak about consciousness in this talk, I'm referring to what philosophers sometimes call phenomenal consciousness rather than functional consciousness. That is, I'm speaking about our incommunicable inner life, our subjective experiences made up of our thoughts, feelings, desires, sensations, and so on, not the externally observable behaviors and activities that may be associated with them. This inner life includes the things that Francis Crick so easily dismissed or demoted: our joys, our sorrows, our memories, our ambitions, our sense of personal identity, and our free will, and much else. It is strange, but sometimes we tend to be so focused on external physical reality, especially physicists are prone to this, that we forget about this inner reality. We literally forget ourselves. There's a story about the ancient Greek philosopher Thales, who lived about 600 years before Christ. It is said that he was so absorbed in studying the stars that he fell down a well. Now, some modern scientists have a similar problem. They're so focused upon the external world of physical objects that they forget their own inner life. Or they become so used to thinking about material things and the relationships among them that they lose the ability to conceive of anything, even their own thoughts, as anything other than material things or as mere shadows of material things. The Nobel Prize-winning physicist Eugene Pvigner once wrote that the enormous explanatory success of the physical sciences has contributed to this forgetfulness. He wrote, "The brilliant successes of physics and chemistry overshadowed the obvious fact that thoughts, desires, and emotions are not made of matter." The eminent cosmologist André Linde wrote about this at more length in one of his physics research papers. Very unusual to find sort of philosophical reflections in a technical physics paper. This is one of the few I've ever come across. But he wrote this long passage. The standard assumption is that consciousness, just like space-time before the invention of general relativity, plays a secondary subservient role, being just a function of matter and a tool for the description of the truly existing material world. But let us remember that our knowledge of the world begins not with matter, but with perceptions. I know for sure that my pain exists, my green exists, and my sweet exists. I do not need any proof of their existence because these events are part of me. Everything else is a theory. Later, we find out that our perceptions obey some laws which can be most conveniently formulated if we assume that there is some underlying reality beyond our perceptions. This model of the material world obeying laws of physics is so successful that soon we forget about our starting point and say that matter is the only reality. This assumption is almost as natural and maybe as false as our previous assumption that space is only a mathematical tool for the description of matter. We are substituting for the reality of our feelings the successfully working theory of an independently existing material world. And the theory is so successful that we almost never think about its possible limitations. Now, before proceeding further, it's important to make a distinction in order to avoid a possible misunderstanding. The issue I am addressing in this talk is not whether consciousness is a natural phenomenon, but whether it is a physical phenomenon, i.e., the kind of thing that can be accounted for by physics. Physicalists claim that it is. What Linde and many others have suggested is that consciousness, while being a feature of the natural world, just as matter is, it may be something just as real and fundamental as matter and not reducible to it. Now, some might object that if matter and consciousness are both features of the natural world, then there ought to be some unifying explanation of both. That is certainly a reasonable supposition. But a unifying explanation of two things, A and B, does not necessarily have to reduce A to B or B to A. Consider an example from within physics. We have an enormously successful and well-established theory of electromagnetism. It gives a unified understanding of both electromagnetic fields and electrically charged matter, or electrically charged particles, let me say it that way. But it treats them as distinct and equally fundamental realities. It does not say that electromagnetic fields can be reduced to or are composed of charged particles, nor does it say that electrically charged particles can be reduced to or are composed of electromagnetic fields. Rather, the theory shows how these two realities are related to each other. There are equations that describe the effects of charged particles on electromagnetic fields, called Maxwell's equation. And there's an equation that describes the effect of electromagnetic fields on charged particles, called the Lorentz force law. In the passage I quoted from André Linde, he makes the use of a different example from physics, namely how Einstein's theory of gravity, called general relativity, treats both material particles and space as equally fundamental realities without trying to reduce one of them to the other. But even if we were to grant, for the sake of argument, that a unifying explanation of two things must reduce one of them to the other, which one should be reduced to which? The philosopher Georges Ray has written, quote, "Any ultimate explanation of mental phenomena will have to be in non-mental terms, that is, material terms, or else it won't be an explanation of it." However, one could just as well turn this argument around and say any ultimate explanation of material phenomena will have to be in non-material terms, or else it won't be an explanation of it. So there's no a priori reason to expect that all mental phenomena, including consciousness, must be reducible to matter or explained by physics, as the physicalist assumes. Now, to be sure, there are very good reasons to suppose that consciousness is intimately connected to matter, and that the two together form a single integrated system that we call nature. For example, consciousness only seems to arise when certain kinds of physical structures are present, at least nervous systems and probably brains. Few people would take seriously the idea that inanimate objects or plants, or those animals that lack nervous systems, such as sponges, are endowed with consciousness. Moreover, we know that physical changes in the brain result in changes in conscious experience in ways that are somewhat predictable. For example, a lower than normal concentration in the brain of the molecule dopamine can lead to the subjective experience of boredom or apathy. Damage to a certain small area of the visual cortex called V4 can strip color from one's visual experiences. The electrical stimulation of a certain tiny region of the brain produces mental states ranging from mild amusement to hilarity, as reported by the researchers, quote, "At low currents, only a smile was present, while at higher currents, a robust, contagious laughter was induced." So it seems justified to say that physical events naturally cause conscious effects, and that matter in certain configurations naturally causes consciousness to arise. The question, however, is whether this natural causation is physical causation, the kind physics can explain. That's the question. There are strong, even compelling reasons to say that it is not. To understand this, one must ask first, how does physics explain things? The answer is that physics explains phenomena by showing how they follow from the basic laws of physics. In particular, physics explains how a physical cause produces a physical effect by showing that the effect can be derived from the cause using the equations that express the basic laws of physics. For example, if one places a cup of water in a microwave oven and turns it on for a sufficient period of time, the water will boil. This can be explained by showing how the oscillating electric field of the microwave radiation in the oven pushes around the electrically charged particles in the water molecules and imparts energy to them, how this energy is dissipated as heat due to collisions among the molecules, the water molecules, and how this causes, in turn, a phase transition of the water from the liquid state to the vapor state. Now, all of this follows from the equations of electromagnetism and other known laws. That is because both the cause, the microwaves, the electric fields in the microwaves, and the effect, the boiling, are both configurations of and changes in matter that are describable by mathematical variables that appear in those equations. By contrast, consider how lowered dopamine levels in the brain cause the feelings of apathy or boredom. How the dopamine molecules interact with various other physical constituents of the brain and the consequent effects on brain functioning can certainly be accounted for by physics, in principle, if perhaps not yet fully in practice. But the feelings of boredom and apathy that result are something quite different. Those feelings are not calculable using the equations of physics, like the positions of atoms within the dopamine molecule. There is no boredom or apathy variable in the laws of physics, nor can one measure and thus quantify boredom and apathy in the same way that one measures the position of atoms. One can, of course, observe and measure physical effects of boredom and apathy, such as expressions on a face or the sounds of groans or tapping fingers. The feelings of apathy and boredom, however, are part of the inner subjective experience of the person having them, just as his or her pain, green, and sweet are, to use Linde's examples. Similarly, there can be little doubt that physics and chemistry can explain how the cone cells in the retina react to electromagnetic waves of different wavelengths and encode that information in signals that are sent up the optic nerves, and how the cells in the V4 region of the visual cortex allow the brain to interpret this information and distinguish waves, light of different wavelengths. But the private, subjective, incommunicable experience of green is something altogether different. The philosopher Frank Cameron Jackson invented a famous argument concerning such sensory experiences, which philosophers call qualia. And he, in his argument, he considered a hypothetical person whom he named Mary, who knows this must be in the future because she knows everything there is to know about the laws of physics. She has complete knowledge of the laws of physics and of human biology, including the physiology of human color perception. But she was raised in this scenario, she was raised from birth in a completely black and white environment and had therefore never experienced color sensations. If Mary then saw the color red for the first time, would she have learned something about reality that she had not known before? I would say obviously yes. But that something that she has learned isn't something she could have derived from her previous complete knowledge of physics and human physiology. There is something about the world of experience, therefore, that eludes the grasp of the equations of physics. That was Jackson's argument. One can make a broader argument along the same lines. Even a complete description of any physical system, down to the configurations and changes of its most basic constituents, whether they be elementary particles such as electrons and quarks, or our superstrings, or something else, and a complete knowledge of the equations of physics would not be enough to reach any conclusion by mathematical and logical deduction about whether that system or entity was experiencing anything, that is, whether it had consciousness. For example, it might be foolish and perverse of me to deny that my dog has consciousness and subjective experience. But if I did deny this, I would not be contradicting anything that we know from physics and chemistry. Nor would I be involved in any logical contradiction. A normally functioning dog, behaving dog, that is running around and barking, but is utterly devoid of consciousness and subjective experience may be contrary to the order of nature, that is, to the way the universe actually works, but it cannot be shown to contradict the equations of physics. Arguments along these lines have been made by several eminent contemporary philosophers, including Saul Kripke, Thomas Nagel, and David Chalmers. They point out that one can conceive of a universe that had the same laws of physics as ours, and that contained living beings that were physically constituted just like human beings or other animals in our universe, and yet utterly lacked consciousness. So we believe that humans and animals in our universe have consciousness, but you could imagine another universe with exactly the same physical laws where animals constituted physically in the same way didn't. There seems to be nothing logically or metaphysically impossible in the idea of such a universe. In our own universe, it does seem to be the case that beings that are physically constituted in certain ways have consciousness, but this cannot be shown to follow by logical necessity from the laws of physics. It is not only some eminent philosophers who have made this point, but some eminent physicists as well. Some years ago, the theoretical physicist Ed Whitten, regarded by many of his colleagues as the most brilliant physicist of his generation, and he's 2 years older than I am, but not only of this generation, but the previous generation, was asked by an interviewer whether he thought humans would ever know the ultimate laws of physics, and whether, if that day came, anything would still remain, quote, mysterious. Whitten responded that he thought several things would likely remain mysterious, including consciousness. These were his words. I tend to think consciousness will be a mystery. That's what I tend to believe. I tend to think that the workings of the conscious brain will be elucidated to a large extent, that biologists, with perhaps physicists contributing, will understand much better how the brain works. But why something that we call consciousness goes with those workings, I think will remain mysterious. Perhaps I'm mistaken, but I have a much easier time imagining how we'd understand the Big Bang, even though we can't do it yet, than I can imagine understanding consciousness. When pressed by the interviewer, who was evidently not pleased by this answer, to define consciousness, Whitten responded, I'm not going to attempt to define consciousness in a way that is connected to the fact that I don't think it will become part of physics. I'm skeptical that it's going to become part of physics. Irn Schrodinger, one of the founders of quantum mechanics, wrote, while all scientific knowledge is based on sense perceptions, the scientific view of natural processes formed in this way, that is, our theories of physics, lacks all sensual qualities and therefore cannot account for the latter. In an interview, he also said, more simply, consciousness cannot be accounted for in physical terms. At this point, a question naturally arises. If physics is not a complete account of nature, as the physicalist believes it is, shouldn't there be some hints of that incompleteness coming from physics itself? If something is incomplete, shouldn't there be gaps or loose ends or ragged edges in it pointing to its incompleteness? And yet, as physics has progressed, its theories appear ever more tightly integrated and rounded off, so to speak. It appears more and more that the ultimate fabric of physical theory will be seamless, woven in one piece from top to bottom, if one may borrow a scriptural image. There is, however, one strong indication from physics itself of its own incompleteness. It was pointed out in 1930 by John von Neumann in his classic book, The Mathematical Foundations of Quantum Mechanics. Von Neumann is regarded as one of the greatest mathematicians of the 20th century. Quantum mechanics, which is the fundamental grammar of all physics, posits two kinds of entities as it's traditionally formulated. Systems, which are observed and measured, physical systems which are observed and measured, and observers who make the observations and measurements of the system. The equations of physics describe systems, but not observers, at least not fully. If one tries to stretch the equations to describe the whole process of measurement, including both the system being measured and the observer making the measurement, one runs into fundamental problems. The problem is that the equations of quantum mechanics only yield probabilities of various possible outcomes of measurements, whereas a measurement to be such must yield a definite outcome. Therefore, if everything is described by the equations, then only probabilities can result from the calculations rather than any definite outcome, meaning that no measurement ever happens. I'll run that by you again. Equations of physics, the equations in quantum mechanics, according to quantum mechanics, the equations of physics ultimately really only yield probabilities of things happening. But a measurement yields not just probability, it yields a definite result. And so you cannot, if you try to describe everything with the equations, all you're going to end up with is probabilities, and you will never have a definite result happening, which means you actually don't have a measurement. This is called the measurement problem. It's the famous measurement problem in quantum mechanics, which has bedeviled philosophers and physicists for almost 100 years. Some eminent physicists have argued that the only way out of this conundrum is to say that something about the observer, in particular his or her knowledge and consciousness, is not reducible to physics and cannot be included in its mathematical descriptions of the world. For example, Sir Rudolf Peierls, a leading 20th century physicist, said, "The premise that you can describe in terms of physics the whole function of a human being, including its knowledge and its consciousness, is untenable. There's still something missing." In a famous essay on the measurement problem, the Physics Nobel Prize winner Eugene Pvigner wrote that materialism, physicalism, is not, quote, consistent with present quantum mechanics. He wrote that in 1961, but we have the same quantum mechanics today. Commenting on this, he said, quote, "It will remain remarkable in whatever way our future concepts develop that the very study of the external world led to the conclusion that the content of the consciousness is an ultimate reality." These conclusions about the implications of quantum mechanics are highly controversial, and most physicists would be very reluctant to accept them. Nevertheless, it does seem that fundamental physics is pointing to its own radical incompleteness. That actually is less controversial. Many physicists believe that it's pointing to some kind of incompleteness. So far, the discussion, and I'm almost done. So far, the discussion has been about physics and philosophy. But some may suspect that lurking behind this discussion is religion. They would be partly right. They may think that I have a religious motivation in arguing that consciousness is not reducible to physics. They'd be partly right. But several points should be made in this regard. First, many of the philosophers and physicists who have doubted or denied the sufficiency of physics to account for consciousness are not religious. That is the case of almost all of those I have quoted earlier in this talk, including the physicist Irn Schrodinger, Rudolf Peierls, Eugene Pvigner, Andre Linde, and Ed Whitten, and the philosophers Frank Cameron Jackson, Thomas Nagel, and David Chalmers. None of them are religious. Second, biblical religion, and Catholicism specifically, do not teach anything about consciousness and whether it is reducible to physics. It would be perfectly orthodox for a Catholic to say that lower animals, despite possessing consciousness, can be entirely understood in material terms. It is not consciousness that is of doctrinal significance to the Catholic Church and Christian tradition, but rather the distinctively human powers of rationality and freedom, which the Church, as well as a long philosophical tradition, claims to be, quote, not reducible to the merely material. So as Catholics, we do have something at stake in question of reason and free will, and whether they are reducible to physics, but not in the question of consciousness. So nothing directly is at stake for Catholic doctrine in the question of consciousness. And yet, it does have relevance to religion in an indirect and negative way. For the irreducibility of consciousness to physics is enough by itself to refute physicalism and or materialism. And physicalism is perhaps the greatest intellectual block to religious belief today. By its sweeping claims, physicalism rules religion completely out of court. If nothing but physical stuff exists, then obviously God and the human spiritual soul cannot exist, nor could many of the other realities that Catholic doctrine and Christian tradition speak about. Most of those today who claim that being scientific means being an atheist hold that view because they think that science somehow points to the truth of physicalism. And yet nothing is more unscientific than physicalism. For science is based on empirical facts. And there is no empirical fact more basic or more evident than that we are conscious. A fact that physical science, by its very way of proceeding, is powerless to explain. Thank you.
So when you raise your hand, make sure the microphone gets to you so that it can capture your words and everybody can hear. What is the first question for Dr. Barr?
Would you argue that consciousness could be explained by some property of emergence where the sum of the neurons is more than just each individual neuron itself, where there's some property that kind of manifests?
I don't think so. Now, emergence is a very slippery term. It is certainly true that physical systems can have properties that the individual constituents do not have. For example, a piece of iron can be hot, have a temperature, but one iron atom cannot have a temperature. So water in bulk can boil, but a water molecule can't boil. So yes, when people talk about emergence, they're referring to the fact generally that some system made up of many things, a complicated system, can have properties, emergent properties, that cannot be found in any one or even a small group of its constituent parts. You need the whole thing there. But nevertheless, I don't think it can be an emergent property in that way, because it can't be, if you are a physicalist, if you are a true physicalist, you think that this emergence has to be explicable in terms of the laws of physics. And we can explain how water can boil even though a water molecule by itself cannot. We can explain that in physics. We can explain how, iron, we can explain bulk effects that emerge from the properties of the constituents using the laws of physics. And what I've been and so emergence, if you're a true physicalist, you cannot believe, I argue that consciousness cannot emerge in any way from matter that a physicalist would be able to explain using just the laws of physics. It does emerge, there's no question. A single atom in your brain can't be conscious. One neuron can't be conscious. But if you put enough neurons together and connect them in the right way, yes, you have consciousness. It does emerge. But I'm not saying it doesn't emerge. I'm saying the emergence cannot be accounted for through the laws of physics. Now, there might be other laws of nature, which we might call, some people have called psychophysical laws. There probably are some kind of psychophysical laws, because you can say certain kinds of physical structures give rise to consciousness and others don't. There's some kind of pattern here. It's not just haphazard. So there's some rules about it and some predictability about it. So there are probably some laws of nature that relate matter and consciousness. I gave examples how within physics there are laws relating things that are not reducible to each other. So there are laws, no doubt, relating matter and consciousness that we don't know yet, and may never know, but we don't know them yet. But all I'm saying is consciousness, however, it does emerge, but laws of physics, as we have understood physics for the last 400 years, as equations that govern measurable things, cannot account for that, my claim. And not just mine, as we've seen, many eminent people have made the same claim.
Yeah, I was curious, because you talked about the universe kind of being, or you talked about experience. Is experience a fundamentally internal or external thing? Or would the universe be the same if there was no one to experience it? And then if that's then true, is then experience and consciousness a fundamentally external thing into our kind of perception? Or is it a fundamentally internal thing imposed on the universe?
So if someone's having the experience, there is a subject of experience. If somebody's experiencing the color red, there's got to be a somebody there. There is a mind having those experiences. The experiences are internal to the mind. So I'd say yes, they're internal to some mind that's having them. Now, you asked another question, whether the universe would be the same if there was no one around to experience it. So suppose life had never evolved. There were no animals, nothing that had consciousness. The universe was dead, barren of all life, all consciousness. Would the universe have been physically different? Well, that actually gets connected. That's a very deep and difficult question, which is connected to how to interpret quantum mechanics, because I mentioned that quantum mechanics as traditionally formulated, what's called the Copenhagen interpretation, also sometimes called the standard interpretation or traditional interpretation or orthodox interpretation, the one that's been taught in textbooks forever, posits that there are, as I said, physical systems and there are observers making measurements of those systems. So somehow the whole formalism of quantum mechanics the whole logical structure of quantum mechanics seems to presume that there's something to make measurements. Now, some people have argued that the observers who make the measurements could themselves just be material systems. But there's a powerful argument that goes back to von Neumann and Pvigner and Peierls and others that no, you really ultimately have to say that observers, it's something about the mind of the observer that is not reducible to physics. And so these people would argue, I think they're right, that the very logical structure of quantum mechanics entails the existence of conscious observers in the world. Or else there's no one to make measurements. Everyone does agree on this. All that quantum mechanics tells you is about results of measurements. That is universally agreed. Quantum mechanics only tells you about results of measurements. That's very different from what happened before quantum mechanics, from the time of Newton up until the 1920s, where so-called classical physics, it was the equations and the mathematics described the world as it is in itself. But in quantum mechanics, it's more subtle. In the mathematics, the equations only tell you not about the way things are in themselves, but how they present themselves to us when we measure them. What it tells us about the results of measurements. It's a very profound difference. And that's why you end up talking about somebody who's making the measurements and observers. So it is an interesting question. If there were no observers in the universe, no minds, what would the equations of quantum mechanics be telling you about? About measurements that no one would be around to make? In other words, that is a profound question, and that's all I'll say about it.
You had quoted Andre Linde and talked about perceptions coming before matter. That's kind of how we.
Our knowledge.
They're not knowledge, but aren't our perceptions like from matter? Like you mentioned the two.
It's talking about what I guess medievals or Thomists in the order of knowledge. Perception comes first. What we know originally is we know our sensations before we know the color of red before we know about electromagnetic waves that causing them. So that you can't. Somebody might deny that there are such things as electromagnetic waves, but he can't deny that he's having a red experience. That's an undeniable primary fact. That's what he's saying. He's not. So at the level, yes. So matter, as I said, gives rise in some mysterious way to mental effects. That's right. You're not going to experience the color red unless you have a nervous system. So the nervous system came first, and then you have experiences in some sense. But he's making an epistemological point. The people who deny, there are people, some sort of hardcore physicalists, because they realize, some of them, that they can't explain consciousness and some other mental phenomena like free will and so on. They can't explain it from physics, deny their reality. That's called eliminative materialism. They deny you have free will. Some of them even say kind of crazily that consciousness is an illusion or something. But the point is, it's an undeniable fact, and that's what Linde's emphasizing. You could deny there's a material world, but you really, which is wrong, but you could do that, and you're not crazy. But you can't deny that you're conscious. That's what he's saying. So they're saying that some people forget, they treat matter as somehow so fundamental that they begin to doubt the reality of their own of conscious of mind. As he said, that's crazy because mind is something we know more certainly is real than we know the physical world is real.
Hi, Dr. Barr. Thank you so much for your presentation. It was very thought-provoking. I have a quick question about human language. Have physicalists ever attempted to physically account for the development of human language? Like, for example, you see something and perceive it as red, and have people tried to make a sort of physical connection to the experience of something red, or the observation of something that would produce that response, and then have that kind of correlate to our word red? I don't know if that question makes sense, but...
Well, all I'll say about language, I'm not a linguist. There's a very good book, which I strongly recommend people read. It's a bit technical. It's not actually written for popular audience, and I think even scientists, because it actually draws on a number of different scientific disciplines, most scientists would have a hard time understanding all of the book. It's by two MIT scientists named Robert Berwick and Noam Chomsky. Berwick, I think, is more a computer scientist. Chomsky's a linguist. It's called Why Only Us? And they're talking about the origin of human language. First, the reason for the title, Why Only Us, is they emphasize that only animals have communication systems. They communicate with you. Even bees have a kind of communication system you could call a language. But human language, they say, is unique. And basically, to boil it down, only human beings have propositions. We can state propositions. And we also have abstract thought, which is closely tied to that ability to have abstract concepts and to have propositional, to be able to formulate and judge the truth of propositions. Only we do that. Chimps, our closest relatives, never put together more than two-word combinations that have no grammar. They're not sentences. And that's our ability to do that is closely tied to our rationality. And that's, I would say, if you're a physicalist, you cannot account, I think, for rationality. Forget language. I don't think you can account for human reason. I don't think you can account for abstract thought. If you start asking how do you explain as a physicalist an abstract concept, I don't think you can do that. And so if you can't do that, you certainly can't account for human language in its fullness. And that's all I'll say. But I would strongly recommend reading the book of Berwick and Chomsky. Chomsky's certainly not religious. Berwick, I don't think he's religious either. I know him, and we've had him speak at the Society of Catholic Scientists conference. He's a great guy. I don't think he's religious, but they strongly emphasize the uniqueness of human language, and I would say that it's not something that could be accounted for in physicalist terms. I think animal communication systems could be. Yeah.
So I know that you said you believe that feelings and emotions and consciousness are inexplicable in physical bounds and are kind of separate.
Physics, right.
Yes, and are kind of in like a separate kind of reality. Would you say then that, do you think that we will ever be technologically capable of measuring consciousness, or do you think that that will be forever off bounds due to its nature?
The way you can know about consciousness is, first of all, by self-reporting. So a doctor will say, on a scale of 1 to 10, how bad is your pain? That kind of thing. So that's one way. Of course, that's quantifying it in some way, but it's very subjective. And what is it? Can you really say the pain is 7.352 on a scale of 1? It's very rough. But so I'm not sure it can really be quantified as a physicist would want to quantify it. And it only can be measured by self-reporting, which is why we can't ask a dog or a cat or a fish if it's feeling pain. People ask, do insects feel pain when you step on them? Does a fish feel pain? I used to worry about that when I caught fish. How am I hurting? No, there's no way to know that, actually, because it's internal, and they can't report on it. Now, we can argue by analogy. I can't ask my dog whether he's feeling pain. I know I stepped on his toe the other day, accidentally, and he's let out a shriek that was unbelievable. And I would let out a shriek, and that shriek would signify that I'm in intense pain. But a physicist would say, all I know is that certain sound waves came out of its mouth. And I could account for that by saying I stepped on its toe. It caused certain impulses to go up its sensory nerves to the brain. That information was processed. Things came down its motor nerves to the things that make it the sound waves, and sound waves came out. I could give a physical account of why the stepping on its toe caused him to screech. I can't know whether there was the same kind, whether he had a sensation of pain. I believe he did, by analogy, because he's similar to us. We're all part of an evolutionary tree. He does a lot of the same things we do. He yawns. He does. He coughs. He does a lot. There are physiologically a lot of commonalities between us and dogs, and I think a dog. I believe he has pain. I can't prove that, though. Certainly not by the methods of physics. And so, no, I don't think we'll ever be able to measure that internal subjective experience.
Hello there.
Although we can measure the concomitants of it. I can see things going on in its brain that in humans are associated with pain. but not the pain itself.
Hello there. My name is Derek. I just want to say that I really liked your presentation, and I definitely agree with parts of it. Specifically how you said, how you said that that physics just simply can't be reduced to anything, and kind of like how physical effects that we can perceive from our own experience are caused by just physics in general. But that also kind of begs the question, because I'm very deep with my faith, and I think that at least everything that I see nowadays, or everything that I perceive in my experience, everything happens for a reason, and I don't think there's any randomness in life. So that just kind of begs the question of what do you personally think is the root of consciousness?
I think it's a natural phenomenon. It's so though I am a physicist, and I think physics explains a lot more than most people who are not physicists realize. Leave mind out of it. You look around you in this room, or go outside and look around you. All the physical stuff that you're seeing, whether it's the sun shining or plants growing or whatever, water boiling, anything you see, physics now either can explain that or has the tools in hand to explain it. But the things that in physics, about the physical world that physics cannot yet explain, are things that are not part of our daily experience, things like what's happened at the Big Bang, what happens at very small distances, much smaller than an atomic nucleus, and things like that. But so physics explains a lot, I would say, virtually everything, but not mind. So, but I do think mind is a part of the natural world. And there's some sort of, and it's somehow lawful. There are some kinds of laws that govern it. I just think physics is not all powerful. Physics is not competent to explain everything. That shouldn't be a surprise. As Pvigner said, nothing is more obvious than our thoughts and desires and so on are not made of matter. As he said, we've gotten so used to the enormous explanatory success of physics that we then think it can explain everything. And that's all, and I'm saying it can't. And the place that is sort of most obvious is with consciousness. But I do think it's natural, a natural phenomenon.
Dr. Barr, thank you for the great talk. This question actually goes beyond a touch the actual topic. You said that quantum mechanics implies, or you think that it implies, the existence of consciousness, or at least of
it seems
human consciousness measuring.
It presupposes that there are, I think, if you follow the logic, that there are minds that are doing the measurements that are not reducible entirely to physics.
To take it one more step, do you think there are any implications from quantum mechanics for the question of the existence of God?
No.
Thank you.
There's a short answer to that.
We've got time for one more question, I think. All right. Is that a hand? Going once.
I see somebody. Yep.
Thank you for your talk. I was just curious, so you've probably seen movies like I, Robot and AI, and so these robots, they have self-awareness, desire, love, hate, all the human feelings. And as AI technology evolves, I assume then you're of the opinion that whatever robots we have in the future, they won't be human-like, right? But just in terms of the experts, what do they say about?
I don't know. I don't. But let me say one thing.
Okay. Yeah. Sure.
I do not have any idea whether you could make a conscious machine, because we don't. Clearly, as I said, physical structures and processes in some cases give rise to consciousness. It does emerge from the functioning of neurons and so on in our brain, in a way that how the consciousness comes out of that is mysterious at the moment. Maybe someday we'll understand it. Though, like Whitten, I cannot even begin to imagine how we'll understand that. He says he finds it easier to imagine understanding the Big Bang than understanding that. But since we don't understand how that happens, I don't see how we could exclude that a brain not made of neurons but made of silicon or something, that we can exclude that consciousness could emerge from that. So I don't know. Have no way of knowing. Nobody else has any way of knowing. What I do, for philosophical reasons I won't go into because that would be a whole separate talk, I don't believe that machines can have reason, can think abstractly, have abstract understanding, and have free will. And this is important theologically, because what the Catholic tradition says, going back to the earliest days of the church, is what distinguishes human beings from other creatures on earth anyway, is that we have a spiritual soul. And what is spiritual about us is that we have reason and free will. Okay? And these powers, these spiritual powers of reason and free will, have traditionally been argued and claimed, it's in the Catechism of the Catholic Church, but it goes all the way back, are not reducible to matter. That's why the human spiritual soul requires a special creative act on the part of God, symbolized in Genesis 2:7 by God breathing. So the body of the human being comes from the earth, comes around through physical processes from the earth. But the spiritual soul, God has to do something special. And so I don't think you'll make a machine that has a spiritual soul that has reason and freedom. But I don't see any fundamental reason, and there are philosophical arguments for that. This is not just based on the church's teachings. There are arguments going back to Plato and Aristotle that would imply that. But I don't see any fundamental philosophical argument against a machine having consciousness.
So I hope you'll join us down the hall for the reception, and I hope you will give a warm, thunderous applause to Dr. Barr.